Welcome to Longevity Industries' presentation of the Destiny of Manufacturing podcast. I'm your host, Dean Phillips. I'd like to thank our sponsors, localenterprise.com. That's Enterprise with a Z. They are the home of the robotic sanitizer known as CodyBot. They do a fantastic job with now with our COVID days. They work really hard to try and keep people safe in manufacturing. I also like to thank the Precision Metal Forming Association for all that they do and the PMA's Educational Foundation for helping to support our show. I have with me today Johan Gout. He comes to us from Capture 3D, and he is the co-founder and Chief Operations Officer. Welcome, Johan.
Thank you, Dean. Happy to be here.
Great to have you here, sir. So right off the bat, tell me what is exciting 5 years down the road. What is it that you see that makes you excited about the changes in manufacturing and what's coming down the road?
All right, to frame my answer a little bit, Dean, Capture 3D provides 3D measurement solutions for inspection and root cause analysis. So what we're excited about is seeing further advancements in the metrology side of things as well. And it seems to be even more important now today than ever is the ability to have intelligent software to automate the solution and then create even a better environment for the user.
I think that's a great way to look at some of the challenges that I think most companies are faced with nowadays is how do we do a better job of, first of all, acquiring information, processing and using that information. So I think that you guys are positioned very well to solve that problem as we move forward. So tell me a little bit about your background. How did you get involved, obviously as a co-founder at Capture 3D, but how did you get involved in manufacturing overall?
Yeah, so interesting enough, I at one time I got to see a lot of companies moving from 2D to 3D CAD. And then I also, after that, got a chance to work at a company called Imageware, which actually is about a company that about 30 years ago was the premier solution for people using scan data. And with them, the data is used for both inspection and reverse engineering. So it was interesting with both of those backgrounds to see how the companies were having challenges in both the manufacturing and inspection aspect of the businesses.
Great. Looks like that was a perfect marriage for you anyways, and really got you into this. The one thing that I always find interesting is how people get into manufacturing, and surprisingly, how difficult it is to get out.
There you go. You're right. With Pratt.
I think that's what happens is you see what is possible, and it kind of it always keeps those juices flowing of how manufacturing works and solving problems. And because of that, I think it's very difficult for people that get that in their blood to get it out of there. It's just very difficult.
Yeah, it is. The one thing too, I'd like to, listening to your other podcast is, give a shout out. This whole thing started for me through going actually to a junior college, where there I got my drafting and design degree and piqued my interest further. And that went into the mechanical degree. And then that's how I got into the whole industry sector. So just a great adjunct to not having to jump right into a 4-year college, doing some of these trade schools and junior colleges, I think is real advantageous for some people.
I started off at a vocational high school, and despite having gone to college for electrical engineering, a lot of what I learned and a lot of what I use in a day-to-day basis, I learned more so at a vocational high school than I did in college. It's kind of interesting how sometimes that plays out.
Yes, it is.
So let's talk a little bit about what you see coming down the road. Can you give us some background on 3D metrology and the problems that you see being solved and manufacturers being needed? They may ask you for, hey, how do I solve this? And how does our quality department find value in this information?
Okay, I'll give that a shot. So the interesting thing is for us, it's been a very exciting scenario because we are dialed in with, EV companies, people trying to get to space, traditional automotive manufacturers, medical, and all of those folks have a bit of a bottleneck that they need to address. And that is one that the time to go ahead and measure their part, create the inspection plans, review the data is a bottleneck for them for the production that they're looking for. And because of that, it adds additional costs to their product. So what we've been able to do is, through this 3D scanning, the ATOS 3D scanner, is to help those companies reduce that bottleneck or actually diminish the bottleneck at times, but then also provide so much more data about their part, their assembly, or even their tooling.
Is the bottleneck specifically more from getting the inspection information or getting it to the right people? Do you feel?
It's actually both. So the idea that we actually scan, we have this dual camera high resolution system that basically takes snapshots of the part. So the speed at which we can acquire the part geometry, the robustness of that data is then allowing the process to happen faster. And then to your second part is the inspection data, which is now more of a visual representation, can then be sent out through the company through a, something we call the ATOS viewer that allows various departments, various organizations to all look at the same data and make a more informed decision.
So how does things like the different types of scanners that are out there, like, for example, like the blue light 3D scanning, how does that help to resolve those kinds of problems?
It's more based on just the robustness of the data. So as crazy as it sounds, when you're using the three-dimensional scanner, we're scanning these snapshots and the system works on a field of view. So it's actually a volumetric measurement. And with that, in this case, one of our sensors has 12 megapixel cameras. We actually end up scanning the part from different angles and different angles of attack. And we end up with a model on the screen, the digital definition of the as manufactured part that actually looks like a CAD model. I mean, that's how much information is in front of you. So now when we take that as manufactured condition and compare it to the CAD nominal position, they actually know exactly what they have in the part that was produced. So instead of just trying to interpret tabular charts of cross sections or maybe discrete points, you actually can see what the part that you manufactured, the characteristics of it.
Do you find it difficult to get that information into other programs or other information compared to, let's say, traditional CMMs?
The good news is we are able to export our data out similar to traditional CMMs. So we are able to go into quality systems for customers. The real neat thing that they're doing with the data, for example, is the idea of capturing that, understanding what their part is, and if they have a next sequence operation for some machining, they actually can use that as their stock model, right? Versus the CAD nominal model that's the perfect representation they may be running their tool paths off of.
Right. Yeah. And I could see that certainly in both in machining and in a lot of the 3D printing aspects now where, yeah, it's great to start with the 3D model, but the reality is that some of the feedback information, if you can incorporate that has so much more value because it takes into account how it was run. It takes into speed, how quickly things were run, spindle speeds or pass speeds when you're doing like 3D printing. And being able to take that information, now you know different results, which is, I think, incredibly valuable when it comes to looking at the quality of a part and accurate representation of what the expectations will be as you get this thing into production or at least into the next process.
Yeah, that's a good point. I mean, the neat thing with the system is the fidelity of the data. We've actually had aerospace customers come to mind where they're actually machining and they can actually see in the color map where the machine tool wore enough that it has an effect on the quality of the part. So for them to able to see that, kind of going back to this industry 4.0, gives them an idea of, hey, maybe we know now that we do need to change this machining tool prior to the part being finished.
Sure,
Yep.
sure. Now, does that also incorporate some level of artificial intelligence where it's becoming predictive as opposed to just, hey, here's what you got, and it's too late, you've already run 20 bad parts? Does it have more of an element of predictive time to failure?
It can facilitate that. Right now, since it's the big data that we're looking at, there's a company that actually manufactures a system, which is ZEISS GOM, and they've got this data package called PyWeb that wants to go ahead and give all that information across the enterprise.
I gotcha. That's great. Now, when you look at 3D scanning as a whole, how does this work to support manufacturers within a range of both simple parts and complex parts and different broad ranges of sizes from small to fairly huge parts that are able to be made on it? Is there a limitation to that, or can you cover pretty much everything?
It's pretty neat because the way the system's designed, it has these interchangeable measuring volumes. So we've taken the ATOS and scanned, for example, the geometry that makes up a stent that goes into somebody's vein, as well as something as large as a C-130 aircraft. So we're able to accomplish that because the system can actually take the measuring field, take it down, for example, to like a 60 millimeter cube volume. So you can imagine now having 12 million points within that cubic volume, or spread it out to possibly a 1 meter volume and then be able to go ahead and cover more real estate quicker with the scanner if the part allows that. And the typical caveat to that is what's the smallest feature you're looking to measure on the part you're measuring. So that typically dictates what measuring volume you'll lose, so you'll be able to capture those small radii or small holes or whatever those features might be.
Okay. Yeah, I always, whenever I think about 3D scanning, I think a lot about photography and how it relates to those kinds of elements of pixels, how many pixels. And like when you're talking about doing larger size parts, I always think of how camera manufacturers do some of the elements of that using more stitching, what they call stitching, where it has some reference it can take from the previous photo and then incorporate it and say, okay, here's where I am on this next set of photos. Is that kind of how that you're working at, or is it strictly based more on position?
Great analogy of what we do. So real quick, one of them is we actually do have a complementary camera system, literally a handheld camera. So when we do this full-size C-130, we place these markers on the airplane. We then do a handheld, what's called a tri-top digital photogrammetry session, and that gives us a constellation of the XYZ center points of the target. That data is then loaded in the ATOS scanner. We bring the ATOS scanner and point it at the airplane, and when it sees 3 of those targets, it actually fits that within the constellation, and now that's how it can go ahead and scan a full-size airplane and keep the accuracy.
Huh. That's excellent. I see a lot of things like in augmented reality where they, in order to try and estimate location, position, rotation, and if it's on a straight axis or if it's tilted, they use what they call these tags. And it's very similar to like a QR code, and it's 1 inch by 1 inch. So if I know that that's the size, if I am off at an angle, it won't be 1 inch by 1 inch. It'll have a different geometry to it. And also, once I get that in position where I want it, then I can fill in all this area around that information because it helps me to pick up that indicator. Do you find opportunities there for more of that kind of element in the 3D scanning process?
Not so much for our solution, which is more of the engineering dimensional type of analysis, but there are other systems that help support that. What we would potentially do, Dean, is be the person to be able to scan whatever parts that they need to build this assembly if they already don't have a digital definition. So then we get in that world of reverse engineering. So we capture for them the parts, we can go ahead and assemble them within the software, and now they can send out that STL file to one of the VR softwares for them to go ahead and do the, a training map of some sort or some kind of an animation.
I gotcha. Do you find a lot of companies coming to you asking you to help them troubleshoot their system if they're already using your 3D system? Do you find them turning around and saying, hey, we're not getting the kind of results we'd like to have? And do they kind of have you either come out, or would they try to do this nowadays, since we're doing so much on Zoom? Is that an element that you guys have incorporated into this?
Yes. I mean, the neat thing for us is we actually have a team, and it's called Launch Services, that we can actually engage with the customer and actually become part of their team dealing with their data and then implementing our best practices that we know, because obviously we're more familiar with the scanner, the process, and the deliverables. So it's been exciting doing that with various types of companies and seeing them be more successful because we're doing that, and it's even a way that we help them launch, the technology within their company.
What are some of the biggest challenges that you've seen from some of the manufacturers that have come to you and said, look, we just need you to solve our problems for us?
It's quite a range. It's what is interesting, because what we've dealt with is companies, the big commercial aircraft manufacturer in the U.S. One of the things that they need to address is that the components from that aircraft come, from all around the world. So the idea that now I need to go ahead and make sure they all fit together, and in various industries, they call something, they do predictive shimming. So that idea that if I know what's coming, I can go ahead and assemble those parts together with the shims already made, versus me waiting to get it into the shop, fit it up, then find out what I need to make the shim, and then, delay the production process that way. So we get involved in a lot of the forward-looking things, but then also, root cause analysis where their turbine blade isn't performing correctly. So, hey, what's maybe the wax that made that blade? Some of the machining operations after to define where they're straying from their design intent.
So does that come in as an element of sort of integration, where you're integrating with all the suppliers, their information, and then pulling it in to give them some kind of a predictive shimming solution?
That is what has been done for various customers. And then we also, to your comment about integration, what's pretty neat is we actually have automated solutions that we refer to as scan boxes. So in the automotive industry, some people may know there's something called the body in white, and that's when they go ahead and construct the frame of the car. And we're able to measure those parts, and then also various organizations, maybe suppliers or that same company globally, will send the other parts of the vehicle, and we're able to go ahead and assemble those virtually, then understanding what they will have for fit and finish.
Is that an industry term? Because I'm not as familiar with that word of that box. What did you refer to it as?
Yeah. So the fit and finish would be more like when you close the door, how well the gap is all around the door, or if it sticks out. And if you look at automobiles, and it's pretty phenomenal now, they typically have these highlight lines that are on the car, and you see them go all the way maybe from the front fender to the rear fender, and that crease, if you want to call it, or that feature actually is a very nice geometry, and it even maybe is on the gas cap of the gas cap of the car. So the difficulty in having that feature be in all those pieces is something that they have to work for under their fit and finish type of application.
Oh, excellent. Now, when you talk about advancements in metrology and inspection, what do you see in the future? What do you think is going to be some of the biggest changes, and how will they better support the manufacturing process as a whole?
I think that's where we fall into a couple categories. One of them is the digital twin. So this idea that I am now getting a baseline for what my manufacturing process produces. So that's outside of this whole idea of the trial and error to get the part to be where they want it to be. But now I know exactly what it is. So now with that information, as I measure consecutive parts, I can tell if it's trending one way or the other. And then also to know when I should take a cost avoidance action to address if the tooling is possibly worn out.
Yeah, I think that digital twins has really taken off as a philosophy and strategy for manufacturers. You start to see more and more of that coming down the road here. And do you think that where do you see that going? Do you see that becoming a benchmark within manufacturing as a whole, or do you think it's going to stay kind of on those higher tier companies like aerospace and automotive that may have more time and perhaps resources to commit to that?
The good news for us is we're seeing it being embraced by many companies and actually kind of as the gateway in to this Industry 4.0. And besides, that being the platform for them to get in, it's such a great return on their investment because, they do want to know what they are producing and they do want to know any effects that it may have in regards to, the part being out of tolerance. Will it potentially get out of tolerance quicker than they would like while it's being in service? And then also when they go ahead and do it in this virtual assembly we talked about, are they getting the assembly and the performance from that assembly that they're looking to achieve? Great.
Do you find that you have because of the high level of technology that you have with your system, is it a steep learning curve, fairly short learning curve for companies to have staff to get up to speed? Because I think everybody's seen where we've dealt with the element of silver tsunami where a lot of people have retired and you're faced with retraining or training new employees a lot more frequently. Do you find that that's better for you or more of a challenge for you?
It is still a challenge, but the nice thing is GOM, the manufacturer of the ATOS system under the ZEISS group, they've done a great job with the user interface. So we've been really both surprised and of course, very happy of the way customers can actually bring it in. It's intuitive enough that we don't struggle too much with somebody who's maybe run more of a traditional CMM, not being able to make the mental switch and utilize the system. The other one is some of the learning aids in it that make it really nice, where it has, for example, a dial indicator. So when you're doing things on the screen, you just pick out of this bucket and you're applying principles quickly to it. And then the real good news is more and more it's getting automated. So that comment about AI, that the system knows that if I'm working on a turbine blade inspection, I know that I want to do a stacking axis. I know I want to do airfoil form analysis and different things. So those things become more available to the user in a more programmed way. So they just have to pick it and apply the principle.
Okay. Is that more of a plug-in that you have for different industries? Like, for instance, aerospace would have its own plug-in, or is that something that they do more on their back end on their system?
More on their back end on their system, but very good comment. So, for people doing plastics, we have functionality. For people doing sheet metal stamping, there's functionality. For people doing forging and casting, and then as I mentioned on the airfoil side. So the recognizing that we've got to make the experience for the user one that is easy for them to assimilate and then easy for them to expand on, actually, because once they understand the principles of the system and how the software is working, there's more power behind that they can go ahead and invoke.
Excellent. Do you think that technology-wise, we are miles ahead of where we thought we'd be, or has somewhat 4.0 under-delivered because it was so overhyped maybe? Or do you think that we are really way ahead of where we thought we would be?
I think we're potentially in a good spot or even ahead of it with the technology, quote, the sensors within the environment. So, as I'm sure you have, you go to trade shows and you're just amazed at the different types of solutions people have come up with. The one thing that all these things are doing is generating data. So I think the toughest part right now is architecting the use of that data.
Yeah.
And it's been real interesting to watch, a 100-year-old appliance manufacturer that we're dealing with moving into not only the 4.0, but just into the 3D world.
Yeah.
Then we've got the automotive companies and aerospace companies that have this great legacy of information they have to deal with, plus, the new information from systems like us. And then you've got the folks that get to take advantage of the greenfield operation, being the EV guys and the guys racing to space flight. So just watching all them in their different stages of getting into this industry 4.0.
Yeah. Are certain technologies more quicker to adopt some of this or slower to adopt depending on the technology that they're in? So if they're in, let's say, like you said, appliance or automotive or aerospace, are they quicker or slower to adopt some of the new technologies, especially like yours, like Capture 3D?
I think they would all like to be quicker to adopt it, but there is the internal challenges of bringing new solutions into an environment.
Right.
So that's what we see a lot of people nervous to start into the whole transformation because they know the quote headaches that will come with it. But the great news is, and especially for us when we're in that inspection world, you can kind of use us as a launching pad to start gathering that data. And it's a boundable solution, if you want to call that, right? Versus going out and trying to attack the bigger animal that sometimes is very difficult and daunting.
Yeah, yeah. How do you eat an elephant? One bite at a time.
With time. There you go.
Yeah, it's true. And I think that so many people, I wonder sometimes if the reluctance to adopt to newer technologies is because of, oh my gosh, this is going to take a lot of work to do it, or if it's, man, I don't want to make the wrong decision.
Yes, I think it's both. And then unfortunately, the war wounds that most companies have from jumping into endeavors that they may think of a similar magnitude and some of the struggles that they had.
Yeah. Yeah. Unfortunately, I think that has kind of made some of the companies gun shy about moving forward on some things.
Yeah. Actually, in our world, it's pretty interesting because, we started the company 23 years ago and a parallel, additive manufacturing was actually in the market space back then, but it was called rapid prototyping.
Right.
Right. So a lot of people think this 3D scanning is a brand new technology, just like people think additive manufacturing just popped up a couple years ago. So unfortunately for certain companies, they haven't had the best experience trying to implement that. Some of them trying to, be the leading edge guys, the forward lookers. So the part that we've got is to be able to show those folks that what they do want to get out of it is obtainable and they're not, sailing uncharted waters, let's say, to get to where they want to go.
Right. Well, sir, we are just about out of time. How can people reach you and find out a little bit more about Capture 3D?
You can reach us on our website at www.capture3d.com. Or you can go ahead and give us a call in our corporate office here in California at 714-546-7278.
Excellent. Great job today. Thank you for being on here and providing us so much insight in the future of manufacturing. Again, I have been Dean Phillips, and I've been your host here on the Destiny of Manufacturing. I'd like to thank again our sponsors, Precision Metal Forming Association and Local Enterprise. That's Enterprise with a Z.